Question 2. Find all functions f from the integers to the integers such that for all integers n, this formula holds.
Well, faced with this problem, I think our first challenge is to ask ourselves if we can find any solutions at all. And if we're going to look for solutions, it's good to stop and think for a moment about what form they might take. But for example, we could think of trying f of n equal to a constant b. But if you think about that for a moment, that's never going to work. And the reason is that this term on the left here, 2f of n, will be 2b, and this will be 5b. So those will be constants, but minus 2n will be minus 2n. So that's never going to be true for all values of n. We can't have constant equals constant minus 2n. A better idea, perhaps, is to try looking for a linear function. So if we try something the form an plus b, we've got a better chance of working. And that's because minus 2n will be linear in n, 5f of n will be linear in n, and this term 2f of n will be a linear function substituted into a linear function, so that will still be linear. So at least it's got a chance of being a solution. Let's see if we can find one. Well, substituting in, we get 2 open brackets a open brackets an plus b, close brackets plus b, equals 5 an plus b minus 2n. Now, if this is going to be true for all values of n, we've got an equation of linear functions, so we've got two different equations to check. We've got an equation for the coefficient of n, and we've got an equation for the constant terms. What happens? Well, so for the coefficients of n, we've got 2a squared here, we've got 5a here, and we've got minus 2 here. So those are the coefficients of n, 2a squared here, 5a here, minus 2 there. And for the constant terms, we get 2ab here plus 2b equals 5b. We can solve these separately, and it's probably a good idea to focus on the one on the left first, because that mentions only one of the variables. Now, this is a quadratic equation in A, and we know how to solve quadratic equations. If we go away and solve it, we find that there are two solutions. We find that one solution is a equals 2, and the other solution is a equals a half. But the condition in the problem says that the solution has to take integers to integers. That means we can't have a equals a half, because if we have a as a half, we'll get non-integer values out. So we can ignore that one and just focus on the solution a equals 2. Now, plugging in a equals 2 into the equation on the right gives us 4b plus 2b equals 5b. So that's 6b equals 5b, which of course means that b has to be 0. So that gives us a possible solution. F of n equals 2n. You could worry about whether it is a solution. In fact, everything we've said so far is reversible, but if you're worried about it, you could just plug in f of n is 2n into this equation and check that it all works nicely, which it does. So armed with our one solution, we should stop and ask if there are any others we can find easily. One thing we could try is plugging in polynomials of higher degree as f of n, but if we think about it for a moment, that's a non-starter. You see, if f of n were to be quadratic, for example, we'd have a linear term here and a quadratic term here, so the right-hand side would be quadratic, but the left-hand side would be a quadratic substituted into a quadratic, so that's a polynomial of degree 4. So we'd have polynomial of degree 4 equals polynomial of degree 2, and that's never going to work. And similarly, polynomials of higher degree is never going to work for the same reason. So it seems hard to think of any solution other than f of n equals 2n, and maybe our mission now is to try to prove that that's the only solution. So an issue we have now is that while we found the solution f of n equals 2n, it doesn't really jump out from this equation in any way. I mean, 2n appears as a term here, but that seems more like an accident than something that's going to help us with the maths. So one trick we can employ is to introduce a new function that measures the difference between f of n and 2n. So we take g of n is f of n minus 2n. And the reason we want to do that is that it might be easier to see that g of n has to be 0 than to see that f of n has to be 2n. So what I'm going to do is I'm going to transform this equation so that it talks about g of n instead of f of n. So of course what I'll do is I'll substitute using f of n equals g of n plus 2n. So what happens when I do that? Well, I get 2, open brackets, g of f of n, so that's going to be g of n plus 2n plus 2 g of n plus 2n equals 5 g of n plus 2n minus 2n. Now we've made rather a mess, but luckily we can tidy this up a bit. So let's sort of multiply out some brackets and see what happens. So we get 2g of g of n plus 2n plus 4g of n plus 8n is equal to 5g of n plus 10n minus 2n. Luckily, quite a lot cancels now. So we've got an 8n on the left, and we've also got an 8n on the right, so all that cancels. And then we've got 4g of n on the left and 5g of n on the right, so all but one of those g of n's on the right cancels. So once we've cancelled out, it looks like 2g of g of n plus 2n is equal to g of n. This is very good news for us. Why is it good news? Well, what this says is that we have a formula for g of n as twice g of something else. What can we do with that? So we've got ourselves a formula that says that g of n is equal to 2 times g of something else. And I'm not actually going to care very much what the something else is, so I'll try not to write it. So g of n is twice g of something, don't care what. But we can iterate that. G of something else will itself be 2 times g of something else again. So this is equal to 4 times g of yet another thing. And that in turn will be twice g of something else. So we can write this as 8 times g of yet another thing. And we can keep doing that. And if we keep doing it, what we find is that g of n is a multiple of 2, g of n is a multiple of 4, g of n is a multiple of 8, and in fact, it's a multiple of 2 to the k for all k. And that, of course, means that g of n has to be 0. 0 is the only number that's a multiple of 2 to the k for all k. But that does exactly what we want. We've shown that g of n is 0, and that shows that the difference between f of n and 2n is 0, and that shows that f of n is 2n. So we found that there's a solution 2n, and it's the only solution.